All right, speedrunners, welcome back to the arena. The active run timer is already counting down, so let's get instantly locked in. Today, we are optimizing your route through a topic that is absolutely mandatory for achieving a top-tier A-star velocity in the Cambridge Mathematics ASNA Level 9709 syllabus. We are talking about the conservation of linear momentum in direct impact. Now, if you're serious about your exam performance, you need to listen incredibly closely, because this specific checkpoint appears in literally every single examination series. Mastering this is not optional, it is the core physics engine of your mechanics paper. Our mark velocity tracker is currently at 0, but over the next few minutes we are going to systematically break down the ultimate route to maximize your marks per minute, eliminate wasted actions, and conquer these high-tariff questions before that time limit hits 0. Let's start the clock.
Here are the run splits for today's explainer map. Split 1, core principles of momentum. Split 2, the technical methodology. Split 3, avoiding examiner traps. And our final boss split, evaluation and critical analysis.
Section 1. Core Principles of Momentum. Let's optimize that theoretical base. Okay, look at the screen. The foundation of any high-scoring, optimized exam response rests entirely on mastering precise definitions. Conservation of linear momentum and direct impact isn't just some basic textbook equation you memorize and drop onto the page. It is a precise theoretical architecture. It dictates the exact causal relationships governing interacting bodies. When body A hits body B, momentum is transferred, never lost. You have to visualize the physics engine here. The syllabus explicitly targets distinct cognitive domains: your base knowledge, your practical application, and your high-level analysis. If you are just trying to brute force the algebra without understanding the underlying physics, your mark velocity is going to tank the second you hit a complex multi-part question.
I want to pull up a quick VOD review here. Let's look at player 1. We'll call him Alex. Alex gets totally bogged down detailing secondary evidence points and trying to outline basic textbook definitions, which causes a massive time loss. He's slowing down to write out paragraphs of theory. But look at what the examiners actually want. Quote, top-performing students exhibit connected conceptual understanding transferable to unfamiliar contexts. Rote memorization is a massive time sink. The examiners are strategically going to spawn entirely new, unfamiliar direct impact scenarios to test you. They don't want a textbook definition, they want to see you take that core conceptual understanding of momentum and seamlessly apply it to a completely novel situation. You need a high-velocity analytical thesis link right on the page to trigger those top-tier marks.
So how do we speed up our mental processing for this? You need a quick bind macro. Create a custom mnemonic using the first letters of the key terms associated with momentum and direct impact. When you are sitting in the exam hall, the clock is ticking down and the pressure is completely maxed out. Having a customized memory hack gives you lightning-fast recall of those precise definitions and causal relationships. It drastically reduces your cognitive load. You aren't wasting precious seconds trying to remember the formula. It's just an instant automated reflex. That way, you allocate your mental RAM entirely to calculating the complex math, keeping your marks per minute budget perfectly optimized.
Section 2. The Technical Methodology. Time to dive into the procedural mechanics.
We've got the theory loaded. Now let's execute the perfect procedural framework. This is a 5-hit combo recommended directly by Cambridge examiners to convert understanding into raw marks. Step 1. Identify the key elements. Instantly scan the text for masses, initial velocities, and directions. Step 2. Apply the relevant conservation principles. Step 3. Execute the analysis with incredibly clear working. No messy scribbles. Step 4. Verify your results. Do a quick logical sanity check. Do these final velocities actually make sense given the impact? And Step 5. Present your final answer in the appropriate format. If you stick to this exact, standardized sequence, you will systematically shred through even the absolute hardest 9709 momentum questions without dropping a single frame.
But listen up, because executing the math is only 50% of the battle. Let's bring in player 2, Sam. Sam is our ultra-fast writer. Sam moves at incredibly high speeds, crunching numbers like a machine, but Sam constantly triggers marking penalties. Why? Because Sam skips command word parameters and ignores presentation conventions. Cambridge is ruthless about this. You must use proper headings, correct terminology, appropriate formats, and crystal clear annotation. If your layout is a chaotic mess, the examiner can't track your logic. Even if your final velocity calculation is 100% perfect, you are going to bleed crucial presentation marks. Do not sacrifice clarity for speed. Smooth is fast, and fast is smooth.
Section 3, Avoiding Examiner Traps. Let's analyze the hazard map.
Time split, check. Before we execute this final top-band paragraph and lock in an A-star grade velocity, you need to optimize your subscription feed. Subscribe to Ace the Exams right now and turn on all notifications. No matter if you are running IGCSE, O-Levels, AS, or A-Levels, this channel is your dedicated tracking center to outpace the clock and beat the examiners. All right, let's look at the telemetry from past runs. We dug directly into the principal examiner reports, and we found the top 3 specific performance leaks where candidates just throw away points. Mistake 1, forgetting to include the proper format. Mistake 2, forgetting to check that format and presentation. The examiners are literally waving red flags here, begging you to present your data cleanly. And mistake 3, providing answers that are not specific to the given context. If they ask about the momentum of the blue railway car after a collision, your final statement must address the blue railway car in that exact context with the correct directional vectors. Do not give generic answers.
Warning, we have an absolute emergency examiner alert on the screen. This right here is the method mark strategy, and it is the single greatest failsafe in your entire speedrun arsenal. Show all you're working. I cannot stress this enough. If you get mathematically stun-locked and completely botch your final calculation, displaying a clear, highly visible analytical process on the page will rescue your grade. Cambridge explicitly awards method marks. If you show the examiner that your underlying physics engine is correct, that you identify the elements and applied linear momentum conservation, you get the points, even if your calculator input was off. Never ever, under any circumstances, just drop a naked final answer on the page. That is an instant run killer.
Section 4, Evaluation and Critical Analysis. Let's upgrade our output.
Welcome to the Interactive Viewer Time Trial. This is where we elevate a standard math response into a top-tier, game-winning analytical answer using the Deconstruct Solve Evaluate framework. Look at the split-screen viewport. On the left, we have standard candidates. They solve systematically. They just plug the numbers in and get an answer. It's safe, but it's slow. On the right, we have the top-scoring speedrunners. They do not just accept the map layout. They question assumptions. They consider different perspectives. Most importantly, they justify their mathematical decisions with hard evidence. The higher-order assessment objectives in the 9709 syllabus demand that you do more than just execute equations. When the command word tells you to evaluate an outcome or compare 2 different direct impact states, you have to justify your pathing.
So here is your explicit optimization template for those high-value comparative analysis problems. If you hit a structural roadblock mid-paragraph, deploy this to smooth out your mark tracking. 1. Actively identify both similarities and differences between the impact scenarios. 2. Use high-velocity comparative connectives in your explanations. 3. Support every single assertion with undeniable mathematical evidence pulled directly from your calculations. And 4. Draw firm, definitive conclusions about the relative importance of your findings. You have to actively compare the approaches and evaluate the alternatives. This is the exact sequence that allows you to clear the mark scheme checkpoints and lock in those top-band A-star points.
Look at that mark velocity tracker. We just hit 100% completion. So, as we hit the victory screen, I want to leave you with one final, provocative question to ask yourself during your final 5-minute quality review pass. Are you just calculating an answer, or are you actively justifying your process to the examiner? Remember that distinction because it is the defining line between a standard run and a world record top-tier result. Optimize your strategy with the 60-second command word scan, manage your marks per minute budget, and always justify your math. Do not forget to subscribe to Ace the Exams, hit that notification bell for weekly speedrun tutorials, and drop a comment below right now sharing which specific Cambridge unit framework you find the hardest to clear under time pressure. Keep your speed up, stay competitive, and I will see you in the next run.